Okay, hello everyone. In this video, I'm trying to explain what is computer security. Uh, Basically, we will talk about cryptographic tools, symmetric encryption. My name is Kurdojaza, and I will now go with the learning objectives. After studying this session, you should be able to explain the basic operation of symmetric block encryption algorithms and compare and contrast the block encryption and stream encryption. Okay, compare block encryption and stream encryption and find out the contrast between block encryption and stream encryption. Now, also we will discuss the use of secure hash function for message authentication, a list of other applications of secure hash function, apply symmetric encryption algorithms in many applications. Now let's start what is cryptography? Cryptography is a technique allow a sender to disguise data or hide the data so that an intruder can gain no information from the intercepted data. In other words, plain text, we have our plain text or we have our message. Now this is Alice. Alice want to send a message for Bob. Uh, our job or cryptography job would be make sure that this plain text will not be seen by Trudy. And how to make that? One of the ways would be encrypting that plain text or that main message. How we will use an encryption algorithm with a key, and then we will send it to Bob via this channel. You see, we will send the ciphertext or the scrambled text. Even if Trudy see this ciphertext, he or she, in this case he, cannot understand what is that ciphertext means. Uh, the only way would be to decrypt the algorithm, and to decrypt the algorithm we will need the key. We will need this key, so Bob has it, and then Bob, after decrypting the ciphertext or the scrambled text, he will get the plain text and knows what Alice intended to tell him. Now, this would be the cryptographic components. We will have a key, we will have ciphertext, we will have a plain text, we will have encryption, and we will have algorithms. Now, you see, in cryptography, we talked about in the previous video, we talked about confidentiality, privacy, integrity, and in integrity, we have message integrity and origin integrity, then authenticity, then non-repudiation. We will talk about what is each one in detail in the upcoming slides. Now, cryptographic tools, confidentiality with symmetric encryption. This would be confidentiality and privacy. Then message authentication and hash function. This would be the integrity or making sure that we will have integrity. Now, confidentiality and privacy attack. Encryption will protect us against passive attacks or eavesdropping. By another word, if information source or this girl want to send his lover or this boy in here a message, she wants to make sure that no one will understand or get or see that message, only this boy. However, if we have an interceptor or intercepted in here, that would be an attack on confidentiality. Now, encryption is one of the mechanisms in order to this girl can protect her messages from those who want to intercept their messages. Now, the history of encryption. You see the history of encryption. Messages must be changed in such a way that cannot be read easily by any party that intercept them, but can be decoded easily by the intended recipient. Or in another word, this person should not be able to see or understand or uh, get the idea behind that message. Only this person. Why? Because she wants to send a message to this person. This girl wants to send to this boy. Then this person is the only one that should understand. And And a few historical methods encryption will be examined. Of course, we have Caesar cipher, we have Rote 13, we have multi-alphabet substitution, we have rail fence, we have Wegener cipher. Now, Caesar cipher is one of those algorithms that has been used in in a very beginning of the time, and it was one of the earliest algorithm or encryption algorithm used, and it is quite easy actually. We will use, for instance, in here, you will choose a number between uh, 1 to 25. Okay, either you can shift one time or two times or three times or 25 times. Okay, so now in this case we have a shift by two letters. Now a shift by two letter, a cat will become CECV. How? Well, we said that we will shift two. So now the A will be shifted by two. Now one would be B, two would be C. Okay, now A became C. How about cat? How about C? C also would be 1, 2 would be E. Then A again would be C. However, for the T, we will shift it twice and it will become V. So this is Caesar cipher, a very easy and very easy to even decrypt algorithm. Now we have a rote 13. Rote 13 is another single alphabet substitution cipher. All characters are rotated 13 characters through the alphabet. For example, the phrase a cat will become NPNG. Okay, and why is that? Because you see would be 1 2 3 4 5 6 7 8 9 10 11 12 13. However, we have something that we need to tell you, that it is, well, in here it is just like array starts from 0, not from 1. So if we say 0 1 2 3 4 5 6 7 8 9 10 11 12 13. 13 would be in here. Okay, now 13 would be n. Now a would be n, and c would be p. A would be n again, the t would be g. Okay, I will let you to also encrypt a dog. A dog, A would be N, and a D would be Q, and O would be, if we find it here, would be B, O would be B, and then G would be, as we see it in here, it would be T, and so on. Now we have multi-alphabet substitution. Example, if you select three substitution alphabets, 12, 22, then 13, then this a cat would be CADV. It means that the first letter A would be shifted by 12 times. Okay, 12 times this A would be shifted. You will shift it all the way until you get that number. Okay, for example, let's say this is A, would we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That uh, the 12th one would be C. Okay, now uh, this C, we will shift it 22 times. Okay, and this A, we will shift it 13 times. Okay, you see in the previous one, this A would be 12, and this A would be 13, because we have a key, we have a triple key, which would be 3 keys. So these are the simple alphabets, and also we will call multi-alphabet substitution because we have multiple numbers. Now we have a rail fence. Now the rail fence is the in the rail fence cipher, maybe the most widely known as transposition cipher. Okay, rail fence we mean, or also known as transposition cipher. You simply take the message you wish to encrypt and alter each letter on a different row. We will start from point 00. Let's say that we have a hello world. Now we will also count the spaces. HELLO. Now we have a space. Here's the space, and WORLD. Now we will write this way: HOREL. Now OLLWD. Horel old, which is hello world. However, in the scrambled way or encrypted way. Now we have a Wegener cipher. Wegener cipher says, well, instead of using a key or rails, I will use keyword. Now, the plaintext of I'm a student, if I wanted to encrypt it using this keyword, it will become such a thing. Well, how does this happen? The thing is, I will write the alphabet from A to Z. Then I will write the CEM, okay? And if it is MEC again, no problem. No problem, I have no problem if it is this way or that way, because it will not be changed. Then let's say this C, the alphabet will start from C until the end. Now from the E it will start, or for this one to start from the E to the end, and for the M it will start from the M to the end. Now I would be, based on this, I will find I, it will be U. You find U, and A became E based on E. A became E. Now C would be M based on the keyword. C would be O. How would I find this? Well, I say, well, this is C, the keyword, and I want to find the M, and here's M, and it would be O. M. Now here's the C and M. And in this alphabet they intercept. Now this is the Wegener cipher, also one of the easiest or the old encryption methods. Now we will talk about what is the modern encryption methods. We have symmetric encryption, logic operation, and or not shift, etc. Also public encryption, asymmetric encryption. Now, the public encryption, asymmetric encryption, we have something we call it number theory. Okay, number theory forms most of the encryption algorithms. Modern encryption algorithm requires sophisticated understanding of a mathematics. Okay, now how about the symmetric encryption? Anytime that I say symmetric encryption, I mean that the encryption and the decryption both they use the same key. That would be the definition of symmetric encryption. And of course, this would be the entire process. I have a plain text, I will encrypt it. Now I will have a ciphertext, then I'll decrypt it, and I will have a plain text again. Okay. Now, how about the asymmetric encryption? Asymmetric encryption, for every person, I will have two keys. Now this would be sender, this would be recipient. The sender will have two keys for itself, and the recipient will have two keys for itself. Now the thing is that sender and receiver, they both have their public key in a very public place. Okay, they don't care about the public key. They say, if anyone wants to send me a message, please use my public key. Now here comes the privacy concerns. Now you see, if they have your public key, they cannot decrypt the message. They, for the decryption, we will use the private key. For the encryption, we will use the public key. Now, this is the entire process in here. Alice sends a message to, says, hello, Bob. She will encrypt it using the Bob's public key. Okay, and then send it to Bob. And now Bob want to decrypt it. This Bob will use his own private key in order to decrypt the message. Now, confidentiality with a symmetric encryption. Symmetric encryption, symmetric block encryption, stream cipher. Symmetric confidentiality with symmetric encryption. We will have a symmetric encryption, which would be the standard encryption. One key will be used for both encryption and decryption. And we will have a symmetric block encryption algorithms, which would be DES, triple DES, or AES, or again, we will also have stream ciphers. So we will have symmetric encryption, we will have symmetric block encryption, and we will have stream cipher. Now let's talk about the requirement for secure use of symmetric encryption. The opponent should be unable to decrypt the ciphertext. Second, discover the key. So if I want to send a message for one of my friend named Ali, this Ali should be the only one that can decrypt the ciphertext or have the key. If there's someone in that between, he or she should not be able to get the decrypted ciphertext or discover the key. If he figured out the key or he or she deciphered the ciphertext without the key, that would be a problem for me. It means that my message is out there in the world and anyone can understand it. Now, the sender and receiver must have obtained copies of the secret key securely and must keep the key secure. Okay, because we know that the symmetric, it will use same key for encryption and decryption. If someone discovered the key and knows the algorithm, all communication using this key is readable, and that would be the breach of our confidentiality. Now, requirement for symmetric would be a strong encryption algorithm. Please use a strong encryption algorithm, or the key lengths. Also, the key lengths would be a requirement if you want to make sure you are secure, or secure key exchange. Okay, you should not send a key in the same email that you send the ciphertext, because now at that time the hacker will get, or the interceptor will get, the key and the message both in the same place. Now, as attacking a symmetric encryption scheme, there are two general approaches to attack symmetric encryption. First would be cryptanalysis. Second would be brute force attack. Now, cryptanalysis would be exploiting the characteristic of an algorithm to attempt to deduce a specific plaintext or deduce the key being used in order to understand the specific plaintext, or getting specific plaintext, or making sure to just understand the key or what is the key. Now, that would be a cryptanalysis. What is about brute force attack is to try even every possible key on a piece of ciphertext until an intelligible translation into a plaintext is obtained. That would be a brute force attack. Now we have a symmetric block encryption algorithms. DES is the first one, triple DES is the second one, data encryption standard, and triple is 3DES, triple data encryption standard. And of course, in 2001, they got the advanced encryption standard because 3DES was quite very slow. Now, the characteristics of DES is the most widely used encryption scheme based on the data encryption standard adopted in 1977. Now, you see, the problem was that the DES used the plaintext block of 64 bits and the key of 56 bits. You see, the 56-bit key number is in here is red because it was relatively small key, okay, to produce a ciphertext. Now, concerns about the strength of DES fall into two categories. Concern about the algorithm itself. DES is the most studied encryption algorithm in existence for the cryptanalysis. Those who do cryptanalysis, they studied a lot, so now they understand how does it work in order to get the real message. Also about the key, 56-bit key is kind of small key. Now, today's supercomputer should be able to find the key in about an hour. That would be a problem if you use DES. Now, the data encryption algorithm would be, DEA would be just like this, 64-bit plain text and 56-bit of ciphertext. We will have 16 rounds and at the final permutation we will have a 64-bit ciphertext. Each time we will have a K1, K2, and K16. Now, brute force attack. With a key length of 60 bits, there are 200 to the 2 to the power of 56 possible keys, which is approximately 7.2 multiplied by 10 to the power of 16 keys. Now, with the old multi-core computers, each multi-core computer, even those who are very old, they can try 1 billion key combination per second. Okay, so with the old multi-core computers, we will need 834 days in order to crack a key. Now the problem is with the contemporary supercomputers technology, a rate of 10 to the power of 13 encryption per second is reasonable. So it will make nearly an hour to find the key, nearly, even sometime less than an hour. Now that DES is not that secure. Triple DES was invented, and they different between triple DES was first it tried to use a bigger key, 112 or 168 bits, which was why we call it DES, because it was encrypt, decrypt, and encrypt. And of course, 3DS is very resistant to cryptanalysis. However, the main drawback was it was very slow in the software. It was using a lot of resources of a computer software. So that's why 3DS was one of those who did not last long. Now, this is the process of triple DES. We have a plain text. We will encrypt it using a key. Then we will decrypt it using another key, then we will encrypt it using the third key, then we will have our plaintext. Now, in order to get the decryption, we will use with the third key, we will decrypt it with this one, then we will encrypt it with the second key, then we will try to decrypt it using the first, or decrypt it using the first key. Now we will have plaintext. Advanced Encryption Standard, AES, Advanced Encryption Standard, is issued in November 2001. AES was very fast compared to 3DES, 6 times faster than triple DES. And it was a block length of 128 bits and key lengths that can be 128, 192, or 256 bits. You see the evaluation criteria included. The evaluation between the ES and DES included security, computational efficiency, memory requirement, hardware and software suitability, and flexibility. Now, advanced encryption standard, you would take the block of message of 128-bit plain text, and then pre-round transformation, use the key encryption of 128 or 192 or 256. So you see, if the key size was 128, we will have 10 rounds. 192, we will have 12 rounds. 256, we will have 14 rounds. So the relation between the round and the key would be very understandable, because each time I have 128, the round would be 10 and 92 and 256, 12 and 14 respectively. Now we will reach the round, and at the last round we will have 128 bit of a ciphertext. Now the comparison of the three popular symmetric encryption algorithm would be 64. The plain text size for DS and triple DS is 64. However, for AES is 128. The ciphertext again would be 64, 64. For AES would be 128. It makes sense because you will feed the machine 64 bit of information of that message, so it makes sense to get the ciphertext of 64 and AES also 128. However, for the key size, the main difference was 56, and for the triple DES was 112, 112 or 168. Well, you see the 168, 112 to 168 was kind of near the AES, because 112 started from 112 or 168. These two keys were available. However, the 160 was nearly near to 192. So the main problem was it's correct that the key size of triple ES was kind of high. However, the software was very slow because that's why they couldn't use it a lot. Now, average time required for an exhaustive key search. Now, for the 56 bits of DES, we will have 1 hour with the time required at 10 to the power of 13 decryption. However, for the ES, we will have 5.3 with a multiple multiplied by 10 to the power 17, and you will get the rest that it will take a lot of time if we wanted to use AES. It will take a lot of time to decrypt the message. Now we have a practical security issue. Symmetric encryption is applied to unit of a data larger than single 64-bit or 128-bit block. Email message, network packet, database record, and other plaintext source must be broken up into series of fixed length block for encryption by a symmetric block cipher. The simplest approach to multiple block encryption is known as electronic code book ECB mode. A cryptanalysis may be able to exploit the regularity in the plaintext to ease the task of description. Now, ECB, the mode, is the most straightforward way to processing a series of subsequently listed message blocks. Now, we will have a plaintext P1, and we will have a key, and we will have a block cipher encryption. Then this block cipher encryption being encrypted, and we will have a ciphertext of C1, and of course plaintext P2 and the ciphertext C2. Now we will send C1 and C2. Then the ciphertext C1 using that block key would be plaintext, and the same for the other one. It will be block by a block cipher encryption or decryption. Now, stream cipher. A block cipher processes the input one block element at a time, producing an output block for each input block. A stream cipher processes input elements continuously. By another word, the stream cipher will not get a block of cipher encrypted and send it, then another block send it. This one will try to make sure to continuously and stream a cipher process an element continuously and producing the output an element at a time as it goes along. Okay, with a properly designed pseudo-random number generator, stream cipher can be secured as a block of cipher comparable key length. So it means that if a stream cipher use 120 and 192 key length, it will be as much as secure as AES if it used 192 key length. If pseudo-random number generator was used, the primary advantage of a stream cipher is that the stream cipher are almost always faster than the use far less code and than the block ciphers. This would be our primary advantage. Now, this would be an activity for you, symmetric key encryption. Write a short message, create a random key and share it with your selected friend. Use one of the following online tools. Create the ciphertext, code beautify, encrypt or decrypt, and the XSEN cryptography triple DES. Okay, and share the cipher with your classmate using WhatsApp, email, or and you ask your friend to decrypt the cipher using the shared key. Okay, however, you should send him the shared key with a different application. If you use Telegram for the messaging, use WhatsApp for the sharing the key. Now we have message authentication and hash functions. Encryption protect against the passive attacks. Eavesdropping. A different requirement is to protect you against the active attack, falsification of data or transactions. Now, integrity attacks means that Halim want to send a message to Anita. Okay, it should be from Halim to Anita. If Alex wanted to change that message and send on behalf of Halim or Halim a message to Anita, that would be an integrity attack because you see the person that want to send Anita is not Halim, is Alex. or falsification. This one would be masquerading or pretending to be someone. Falsification attack would be if Bob wanted to send Alice a message, the man in the middle, or Darth at this one, will get the message and will change it and send it to the Alice, and so Alice will get a false message. Now, authenticity attack or non-repudiation or repudiation of origin means that once a person sends something to the bank, should not be able to say that I didn't send that transfer or I didn't send that thing. Okay, the authentication should be acquired by that person. Now, what is the authentication means? We will explain it furthermore. Now, message authentication, you see again, we said that the encryption protect against passive attack only, okay? However, what about the message authentication protecting against active attack, okay? So encryption would be for passive attack, authentication would be for active attack or integrity attack. Now, falsification attack, authenticity attack, and repudiation problem would be the type of message authentication protection. Data or content integrity and message origin authenticity. Now, message authentication and hash functions. Authentication using symmetric key encryption. Now, message authentication without a message encryption would be message authentication code one-way hash function. We will use these two in order to authenticate a message, of course, with no encryption. For secure hash function, we may use hash function requirement, security hash function algorithms. Now, how about the other application of hash function? Password, intrusion detection, and cryptocurrency would be those application of a hash function that regularly use hash function. Now, the message authentication and a hash function. A message or a data authentication is used to do what? To protect against active attack. Of course, the type of active attack, we said that it will be falsification of data and transaction, okay, and data integrity, okay. So active attack would be data integrity, passive attack would be data confidentiality. A message, file, document, or other collection of data is said to be authentic when it's genuine and came from the alleged source. Okay, when will I say that this message is authentic? If I get it from my friend Ahmed and he really did send me that message. If he did not, that would be a problem and we will not say that this is genuine. Okay, this is not original message or data authentication procedure that allow communication parties to verify that received or stored message are authentics. The two important aspects are to verify that the content of the message have not been altered and that the source is authentic. So we have two important aspects. First, we make sure that the message is not being changed or modified, and the Ahmed is the really is that person that sent me, not Alex or Darth or let's say Trudy. Now, authentication using symmetric encryption. If we assume that only sender and receiver share a key, which is should be the only genuine sender would be able to encrypt message successfully for the other participant, provide the receiver and recognize a valid message. Okay, what do I mean by this? If let's say that I have a key with my one of my friends, we have a key which is our secret key. At this time, only I will be able to encrypt the message, and my friend would be the only person to make sure that will decrypt the message. Now, message authentication without message encryption. You see an authentication tag is generated and appended to each message. What is the authentication tag? It is just like this red wax seal on the medieval time that they used it in order to make sure that this message will not be opened. Okay, and message origin, message authentication is the message altered data integrity. Now that that letter will have the information, and in order to make sure that the message is not altered, in the medieval times they used the wax seal, and this way if the message was opened they would have known. Now, why message authentication without message encryption? Because sometimes, like a broadcast, is a non-confidential data. Message integrity important. We want to make sure that the broadcast everyone sees the content of the broadcast. Let's say API. However, it is important to make sure that no one changed the broadcast API. And the time resource, random checking for the speed. Okay, instead of encrypting everything, it will take a lot of time resources. uh, we will only check for the chunks of that data. Processor resources, of course, authentication tag smaller than the size of the message. Message authentication can be achieved using message authentication code or one-way hash function. Now, message authentication code or MAC would be just like this. We will have a message, and that message using an algorithm will be encrypted and will get its own HMAC, okay, or the hash MAC. Now, the Alice will send the message to the Bob. Now, Bob will try to decrypt the algorithm and again produce the HMAC. Now, HMAC being shared with Bob also. She will check if the HMAC that he did get from decrypting the algorithm and the one that's get from the Alice are the same. If they are the same, so that would be there's no problem with the authentication and no one has intruded that message, and so the integrity of the message is not being compromised. Now we will have one-way hash function. One-way hash function is a hash function accepts a variable size message m as an input and produce a fixed size message digest h and m as an output. It means that it is like just like this grinder. We will input our message and it will give us a very fixed size message. Okay, if we change only one space of that message, the hash function will be changed, and that time we will have our problem. Now, how does it work? Fixed length output, hash value, efficiency of operation. Now, what does it mean? Fixed length output. Hash function can convert data of arbitrary lengths to a fixed length. This is a process of often referred as hashing the data. In general, the hash is much smaller than the input data, hence the hash function are sometimes called compression function. Also, this might be asked, does the hash function also called compression function? Well, this is the important part. Since the hash smaller representation of a large data is also referred as a digest. Hash function with n bit of output referred to as an n-bit hash function. Popular hash function generated value between 168 to and 512 bits. Efficiency operation generally for any hash function h with input x, computation would be h, and x is a fast operation. Now, pre-image resistant one-way function. It should be computationally hard to reverse a hash function. H and X equal to H, small h. If you know the H, or if you know the algorithm, and uh, if you got the hash function, it is still not feasible to get the entire message or get the X. Okay, that's why it is quite uh, hard to get the entire message. Second, pre-image resistant, weak collision resistant. It is computationally infeasible to find y is not equal to x, then h and y equal to h and x. Okay. Now, collision resistant, strong collision resistant, is computationally unfeasible. So we cannot do it computationally to find x and y, such as that h and x is equal to h and y. Not y and y is not equal to x, not even h and x is equal to h and y. We cannot find this. Message digest, or MD. MD was the most popular and widely used hash function for quite some years. The MD family comprised of hash function MD2, 4, 5, and 6. It was adopted by the Internet Standard RFC 1321 with the 128-bit hash function. Secure hash function, or SHA-1 will use 160-bit, SHA-2 will use 250, SHA-2, SHA-256, SHA-384, SHA-512, and SHA-3 was 160,000 bits. RIMT wearable, this is wearable is this is 500-bit hash function, also is another type. So we have MD, we have the secure hash function, and RIMT and wearable. Now, secure hash function algorithms. It is only, let's say, kind of an history of the SHA secure hash function created by Nest. SHA-1 FIPS entered in 1994 produced hash value of 160-bit. SHA-2, as we explained it in the previous class. What does it mean? We have a message. We will feed it to the grinder of the hash function. We will get a value, a fixed value. Okay. Now we will encrypt it with a key. We will get this. Now we will send this value with the message itself. We will not encrypt the message. We'll just send it like that. We want to make sure that the message is not altered, no, it's not modified, uh, not change, not uh, make sure that it is not changed. The message is not changed. Then the recipient or the destination will get the message, and the message again, he will do the hash function again and decrypt with the key, of course. Then he will compare the result that will get from the decrypt with this one. Okay, if these two are compared to each other and they are just like each other, they are identical, so there is no problem, there is no attack on integrity. Otherwise, yeah, there's an attack on integrity. Now, public key encryption, instead of encrypting using a key shared between these two, the process of public key will be used. Public key will be used for encryption and sending a message. Then the message is received and will be hashed. Okay, and of course the part that has been sent also would be decrypted using the public key. Then we will compare these two. If they're identical, so there's no problem. Now, secret value, we will have our message with the key, and we will all fed it with the hash function, and we will send this hash function with the message. Then the person will get it. Once it will get it, this person, the recipient, will add his own key that has it and is private. It will fed it the entirely with the message with the key from the beginning and from the end. So we'll feed it to the hash function, and it will get the hash function, and then the part that has been sent, this part, will be also be compared with the value that get it in here. Now we will have a lab activity using a hash function. Now this would be our lab activity. 2. Using hash function, open Windows PowerShell, create the text file and write some text message. You can generate the hashes of them of the following. 1. The quick brown fox. Okay. And second one, we did the quick brown fax. The O changed to A. Okay. Execute the following: get file hash target file path, then format list, and get file hash target file path minus algorithm SHA-384 pipe format list. Compare the hash value generated from each two sentences. You can see the following online MD5 tools. We will also have the mdhashgenerator.com would be an online tool. Now, this would be another lab activity. Since now we don't have any lab activity, please do it by yourself. And once you got the result, you will understand what we mean by hash, and when we say that even a simplest change will make sure that the entire hash will be changed. Now, avoid encryption the whole message. Encryption software is quite slow. Encryption hardware costs are negligible. A low-cost chip implementation of a DES and ES are available, but the cost adds up if all nodes are in a network must have the capability. Encryption hardware is optimized toward the large data size, and encryption algorithm may be protected by a patent. Now, secure hash function. The one-way hash function or a secure hash function is important not only in a message authentication but also in the digital signature. A hash function H must have the following properties. H can be applied to the block of data of any size. H produces the fixed length size. H and X relatively easy to compute for any given X, make both hardware and software implementation practical or easy to be implemented. For any given code of H, it's completely infeasible to find X. It is just like a summary, like we explained it before. Now, for any given block X, it's infeasible to find Y is not equal to X with the H and Y or H and X. Single premise resistant with collision resistance, and again, it is computationally infeasible to find the pair of X, Y, such as X and A collision resistant, strong collision resistant, two messages have the same hash. So no two messages in worlds will have the same hash. Okay, no two different messages will have the same hash. If the message, if two messages are identical, they will have the same hash. Now, security of a hash function. Cryptanalysis involve exploiting by logical weaknesses in the algorithms. Brute force attack. The strength of a hash function against the brute force attack depends solely on the length of the hash code produced by the algorithm. Now, what are the application of a hash function when these hash function will be used in the authenticity, in the password protection? For example, you when you store the passwords in the database, make sure to hash it. Digital signature, blockchain, data integrity check, intrusion detection, and antiviruses. Now, in our next session, we will talk about the cryptographic tools, asymmetric encryption, which is the public and private key. Thank you very much, and I wish you have a nice day.